Today, we'll be presenting on our 2016 and 2017 Senior Capstone project, which is entitled Augmented Context Visualization Using Geospatial Twitter Data. And my name is Raquel Lippincott. So for this project, we've been working with the Data Mining Machine Learning Lab on campus, which is headed by Dr. Liu. And from this lab, we've worked with a number of graduate students, which include Liang Wu, Kai Xu, Justin Sampson, and Fred Morstater. And in the fall, our capstone instructor was Dr. Balasaria, and our capstone TA was Sapasish Das. And then in the spring, our capstone instructor was Dr. Devolku, and our TA was Mohammed Hekmatnejad. So for this project, we need to expand on the lab's existing tweet tracker tool. So this tool focuses on tweet collection and world events. So our motivation was to integrate geographic data and provide context and event density distribution. And although the tweet tracker tool was is a standalone application, we needed to build our own application from the ground up. So from there, we had 3 different sub-goals. So the first one was data gathering and storing the data in a database. And then our second goal was analyzing the data from the database using semantic analysis. And then our third goal was visualizing the analysis data using a web application. So now Matthew Gross is going to talk to you about our decision process.
Okay, so at the beginning of the semester, we decided to split into 3 separate teams to tackle this project. We had the data gathering and backend development team, the analysis team, and the visualization team. Now, on the backend side, we had to worry about how we were going to get tweets into the database, what streaming methods we were going to use to accomplish this. But more importantly, we had to worry about how we were going to query the database and get the tweets from the backend to the front end. On the analysis side, they had to worry about the data cleanup, specifically what parts of the tweet we were going to keep and how we were going to create a cluster of topics from these tweets. On the visualization side, we had to worry about what was going to be represented on the map itself and how they were going to get the tweets from the back end to the front end and how they're going to display that. Now, we've made quite a few changes from the beginning of the semester. One being we originally had a single tweet for a given region. Now we get a list of topics within a given region instead of just displaying a single tweet. We also now allow for the selection of global and local regions. We also can cluster in multiple sizes, such as small, medium, and large. And up next, we have Christina Wilmot, who will talk about the system architecture.
All right, so overall, as far as the actual architecture of our implementation, we split the implementation into 2 separate components. We have our web scraping and tweet gathering component, which uses a series of access keys for the Twitter Developer API, and it rotates those access keys and uses those keys to get information from the Twitter Developer API. It has the stream constantly flowing those tweets in, and then it stores those tweets off into our Mongo database. We used a Mongo database because, first off, the lab that we were working with primarily uses Mongo for all of their tweet storage, and so they already have the infrastructure in place, as well as the fact that Mongo is a non-relational database, which works well for the structure of the tweet objects that we were getting from the Twitter Developer API. On the other hand of the implementation, we have the actual website, which users can go to and input certain information, such as a date range, whether or not they want to cluster into topics, and a general geographic region, what area do they want to analyze. So all of that information is input by the user. The front end grabs that information and passes it via an AJAX call to our RESTful endpoints, where the backend handles that request. It takes all of those input parameters and queries on those parameters to our Mongo database for the correct tweets. Those received tweets are passed back to the backend, and then the backend handles all of that tweet data over to the analysis side. The analysis will then clean the data, it will do the analysis, it will do the clustering algorithm, and pass back the topics and their clusters to the backend endpoints, which will then return from the request to the front end all of that same information. The front end puts that into a user-friendly visualization tool, which passes back to the user. As far as our actual technologies used, for the visualization, we use the Mapbox API because it allows for us to dynamically add objects onto our map, along with GeoJSON where we represent those individual objects. We used typical front-end development such as HTML, CSS, JavaScript, along with jQuery and jQuery UI for dynamic allocation, and Bootstrap for design. The backend again uses MongoDB because of the aforementioned reasons, along with the Twitter Developer API, which allows for an easy access of tweet information. We use TweetPy, which is a Python package which allows the developers to hit the Twitter Developer API, and Flask for our web service hosting. The analysis did a latent Dirichlet allocation in order to find the top topics. We used GenSim's open source library to do that LDA analysis, and GenSim also had topic coherence, which we were able to do to find the best topics. We wrote our own clustering algorithm, which is loosely based on KD trees, which creates more clusters for densely populated areas and has fewer clusters for less populated areas. And then for data cleaning, we used the Python natural language toolkit along with stop words to clean out the information we didn't need. And next up is Philip, who will be talking about our results from the data streaming component.
Here are some of the results of our data components. The mechanism of rotating Twitter user keys for our data stream ended up being very successful, and we were able to run our streams for 24 to 48 hours straight without hitting any rate limits. We were able to create multiple data storage collections in our Mongo database to perfect the kind of data we wanted to insert. For example, our test1 collection first inputted all the data we got from our stream to see if it was working. The next correctly JSONified the tweets, and then we included only geotagged tweets because we only wanted tweets with location coordinate data. And lastly, we were able to correctly format the dates of the JSON tweets so that we could more efficiently query on them with their longitude, latitude, and date range. By the end of the project, we had roughly 500,000 tweets in the database, and that was by only running the stream a minimal amount of time. We could have a lot more if we had extra stream running. And we ended up being able to successfully query on a longitude and latitude range, as well as a date range given that we'll see was necessary for the visualization. And now on to Spencer, who's going to talk about the results of the visualization side.
Alrighty, so here we can see the front end, or what we developed for the front end. Here is an example of what a user will see when they initially load onto the screen. So we embedded a map using the Mapbox API so that we could easily have users interact with the map as need be. There are two tabs, the selected area and clusters. When starting on the selected area, the user will select the begin date text field in which a calendar will pop up to be able to easily determine which begin date they want to use. Then they will do the same for the end date. Once they press the Retrieve Topics button for the selected area tab, we will populate one region with a number of tweets or a number of topics that the user can see when they hover the mouse over the region. Then we have the clusters tab, which is similar, except we use multiple bins when the analysis is performed, resulting in a number of regions that the user can hover over to view which topics are in this region. Something good and bad things about this, with the way that it is developed currently, it is not very mobile friendly, so it'll be a bit more of a hassle if a user is wishing to use this on the mobile. Also, with how it is currently implemented, there isn't a way for the user to have a historic playback over a date spread. On a positive note, we used Bootstrap, for example, to aesthetically boost the UI so that it's not overly clunky. Up next is Corey McNeish with our items learned.
We learned a lot about how to manage a larger project than some of our previous classes this year. Probably one of the main things we learned was how to really get our time management down. From the start, we had weekly meetings with our sponsors, and they didn't ask a lot from us, but we kind of gave ourselves goals from each meeting to each next meeting to try and make sure we're making progress, and that has really, really worked out. I mean, we finished our project well ahead of schedule. We had some scheduling issues because we're such a large team. It was difficult to find time where everybody was available, but once we started scheduling those well ahead of time, like a week out, it was fine. We had a couple problems with like project management wise, where like some parts of the project were inconsistent with other parts, but we went through and we tested those and we reviewed like what we had so far, and it worked out fine. We learned a lot this semester. Some of us hadn't had much Python experience before. None of us had really had any web development experience, and some of the libraries we learned were really interesting. So we'd really like to thank our sponsors, thank the TAs, thank the professors, because we really enjoyed this.